Hello, in this video I'm going to talk about how to show biconditionals. So, biconditional, let's say you have a biconditional box if and only if circle. How are you going to get that? Well, we have the rule CB and that's what we're going to try to apply. So we need to get if box then circle, and we get if circle then box, and then we can apply the rule CB, and that just lets us go from those two to the biconditional. And then we can apply direct derivation, and that boxes and cancels. So the question is then, once you get the conditionals, you're good to go. How are you, once you get the conditionals, you know I can apply CB and then DD. So how do you get the conditionals? Well, there's really actually in this case just one main way, and that's by showing them. So I'm going to go over to the derivations module now, and we're going to see some examples of getting biconditionals. We're going to start with some simpler examples and then build up to cases where the sort of normal cases where you really have to show both of the biconditionals. So let's take a look. And let's make this big. Okay, good. So here we have about as simple a problem involving biconditionals as we could, because we just have as our premises the biconditional going from left to right, and the conditional going from left to right, and the conditional going from right to left of this biconditional, right? The left to right biconditional is if P then Q, and the right to left biconditional is if Q then P. And that's what we have on lines 2 and 3, so we can just apply CB, and we'll get DD. By the way, if you see this is derivation 2.6 LRS 165, so this should be in your derivations module, so you can open up the module and actually just follow along with these derivations as I work through them. I highly recommend that you do that because I think you'll find it really helpful and absorb the material better. So I'd suggest actually right now you pause, open up the program, open up the derivations module, and open up 2.6 LRS 166 actually, which is the problem that I'll be working on next. So go ahead and pause it, and then when you're ready to go, come back. So here we are on 2.6 LRS 166, which hopefully you have open in your own derivations window. And if you don't, I'd go ahead and pause this video and open up the derivations module in the program and get this problem open. So we'll go ahead and say start with show conclusion, and now we'll bring in our two premises. And here we have if P then Q, and if not P then not Q. So we want to get if P then Q, and if Q then P, and then apply CB to get the biconditional, and then just box and cancel with direct derivation. We have one of the conditionals, we have if P then Q. So we want the other condition, right? We want if Q then P, because with that in line 2 we can get what we want. Well, we don't have if Q then P, so we need to show if Q then P. Because how do you get a conditional? Well, almost always the way in which you get a conditional is by showing it, by putting in the show line and then later canceling the show line. So okay, we have this show line if Q then P, so let's go ahead and say assume CD. Now we don't have to, but in this derivation, but just to make sure we're in the habit, we can also say show cons, because once we get the consequent P, we can box and cancel. We can apply, once 6 is canceled, we can apply CD to line 6, and that will cancel line 4. Okay, well, with P, we can make an indirect assumption. So can we use not P? Sure, we can use not P with line 3. So we'll say 3, 7 modus ponens, and that gives us not Q. What should we do now? Well, if we look, we can see we have Q on line 5, and that contradicts line 8. So if we bring line 5 down, if we bring Q down, now we have a contradiction Q, a negation Q beneath line 6. So now we can say 8, 9, ID. So now we have, so just, right, once you start with an indirect assumption, then you're looking for a contradiction, and that's what we got pretty straightforwardly. So now we have P, and we said, well, if we have P, we can apply CD to it, and when we do that, we'll cancel line 4, because 6 is the consequent of line 4. So we'll apply CD to 6, and that's going to cancel line 4. Okay, good. So now what were we doing with line 4? Well, we're trying to show, let's remind ourselves, the conclusion, P if and only if Q. And how do you get and that's a biconditional. How do you get a biconditional? You get the left to right conditional, and you get the right to left conditional, and you apply CB. And now we have the left to right conditional if P then Q, and the right to left conditional if Q then P on line 4. So we can say 2, 4, apply CB, and we'll choose P if and only if Q, and that is a direct derivation. Okay, so here the difference between this one and the first one is, well, we had to do a subderivation because we didn't have both of the conditionals. We want to get the conditionals to apply CB, and that's really the only way we're going to be able to go normally. If you don't have the conditionals, then you need to do subderivations of whichever conditional or conditionals you don't have. Okay, let's take a look at another problem. We'll go on just to the next one, 167. Okay, so again, we'll say show the conclusion, and now let's put in our two premises. And now here, we don't have either of the conditionals. It's a biconditional, so we want to get the left to right conditional and the right to left conditional, so we want to get if P then Q and if Q then P. We have neither of them. So we want to show both of them. And fortunately, there's actually a show command, just like show conclusion writes show writes the conclusion, or show conc will put in a show line with the conclusion. There's a show command show cond for show conditional. And that, if you use it beneath the biconditional, it will say, oh, I will write either of the conditionals for you. So show cond says, I'm going to insert a show line for you. It says, I'm going to insert either of these for you. And these are the two conditionals that we want to get first, to use CB to get this biconditional. So we'll go ahead and let's say if P then Q. So let's say assume CD. That gives us P. Let's go ahead and say show the consequent, because once we box and cancel 6, we can apply CD to 6 to cancel 4, right? Because 6 is the consequent of 4. Well, let's make an assumption. We can't make a conditional assumption, so we'll assume ID. So let's see. Can we use P or not Q? Well, if we look at 3, for modus ponens with 3, we need negation P, and we don't have that. For MT with 3, we need negation Q, and we don't have that. So we don't have negation P, and we don't have negation Q. And we can't get either of those by applying dn to 5 or 7. We could get negation P, but that's not going to help. And we can get triple negation Q from line 7, but that's not what we need for MT with line 3. So let's see if we can use 5 or 7 with line 2. Well, in fact, we can use 7 with line 2 because 2 is a disjunction. The right disjunct is Q. And what we need for MTP is the negation of either of those disjuncts. So we need, for example, negation Q, and that's what we have on line 7. So we can say 2, 7, MTP. 7 is the negation of the right side of 2. And we get not P. Well, good. What can we do with not P, or with negation P? Well, one thing we can do is we can look for contradiction, and indeed on line 5 we have P. So 5 and 8 contradict each other. That's what we need for an indirect derivation. So let's move 5 down, and now we can apply ID to lines 8 and 9, and that will box and cancel line 6. Good. So 6 is the consequent of line 4, so we can apply CD to 6, and that will box and cancel line 4. Good. Are we done with the derivation? No. We're trying to show P if and only if Q. How do we do that? Get both of the left to right conditional of P then Q and the right to left conditional if Q then P, and then apply CB. Well, so we're done with half of this because we got the left to right conditional, but we also want to get the right to left conditional. We want to get the conditional if Q then P. So we'll do show conditional again as a separate subderivation. So we're doing two separate subderivations, right? Just like with a conjunction, you do a subderivation for one, you might do a subderivation for one conjunct, and then you separately do a second subderivation for the next conjunct. Same thing here. You do a subderivation for one conditional, and then you separately maybe do that may not be enough. You may still need to get the other conditional, and if you do, then you separately do a second subderivation. So here we have if not if Q then P. So we'll say assume CD to give us Q. We'll go ahead and say show consequent, because again, if we get the consequent, we can box and cancel 12. And we'll make an indirect assumption because we always want to make an assumption, well, more or less, unless we have some other strategy we're pursuing, and we don't. And the only assumption we can make is indirect derivation. So can we use Q or not P? Yes, we can use not P because not P, line 15, is the antecedent of line 3. So we can say 315 modus ponens, and we get not Q. Can we use not Q? Well, not Q is the contradiction of line 13. So we'll move 13 down, and we have what we need for an indirect derivation. Good. So now we'll say 14. Well, 14 is the consequent of line 12. So if we apply CD to line 14, we can box and cancel line 12. Now, what can we do with 4 and 12? Well, they're the left to right and right to left conditionals from line 1, so we can put them together to form line 1, and that's again a direct derivation. So that's this is the most general sort of approach to getting a biconditional. You start with show the biconditional, and then you show each of the component conditionals, the left to right conditional and the right to left conditional. You apply CB, and then you box and cancel with DD. And you can use show cond to write in those two conditionals for you. It's not a justification. You can write any show line you want, but it's just a shortcut that will punch this in for you. Just like this is not a justification of this. These are not justifications of these. They just are shortcuts for entering the initial show lines. So we'll pick up in the next video with some more examples of biconditional derivations of biconditionals, and we'll also summarize the strategy we've been talking about. So you can go ahead and get started in the next video. You might want to take a short break, but then go ahead and we'll just be looking at derivation 2.6 LRS 168.